This section looks at loading test programs and the use of part numbers. The screen that controls loading a test is this Choose a Test page, and there are three main options: enter part number, load a test, and manufacture a test. The simplest of all of these is just to load a test sequence. If you click this button, you get a file open dialog, which is just a list of previously saved test sequences. These can be saved by any particular name that you choose. So in the simplest instance, it's quite adequate to construct a test program for a particular part and then to save that test program under the part number that you wish to save. That way, when that part number is to be tested again, the operator selects that particular part and loads the test program. That's okay until you have a lot of parts that are very similar electrically to one another. And this is where this part number button comes in. If we click on this part number button, a wizard starts up that prompts you with a list of previously entered part number types. This list is filterable, so for example we can type in 5V and the part numbers that have 5V in them appear. This allows the operator to type in part of a part number and to see a much reduced list of what they should choose. So let's go ahead and select this particular part, Form A read relay 5 volts 500 ohms. We get a confirmation, and after entering a few more details we're taken back to the home page again with a ready to run test program. Now the interesting thing is what's gone on behind the scenes here, because the part number that we entered did not directly correspond to a test sequence file. It used a generic test sequence file. If we look at an example of a test program, you'll see that each line contains a series of data for one particular condition. So this line shows us that the maximum coil resistance limit was 88 ohms. Now if it were possible to change this 88 on the fly to something that applied to the specific part number that the operator has just chosen, we could use the same test program to do a number of different parts. And that's actually exactly what we do. We use two special files, one a devices list and the other a mapping list, to allow individual rows to specify simple electrical values, like here, that will replace the electrical values that are already in a generic test program template. So for example, on this row here, which is the row that we have selected, if I go down and select the actual part number that I entered, there's the part number that we selected earlier on. The values here, for example, R coil min, the minimum coil resistance, is 400 ohms. This value will be placed under condition C414 in the generic test program by the test program generator after the operator has entered the part number, and this happens entirely automatically. So the original test program is here, ART example part number source. This is the original test program that's used, and it will be loaded and then it will be modified on the fly with these values that you see on this row here. Every single value will be used to replace the original value in the test program, and then that test program will be loaded ready for use. And the result is the test program that you see here in this list. Now the benefit of this is that if you've got maybe 20 devices, all of which are only slightly different to one another electrically, those electrical differences can be encoded in the part number list, and you can use just one single test program to handle the electrical test order of each of the test sequences. And this makes maintenance of the test programs much easier than trying to keep 20 test programs up to date and in track with one another. Here you can modify the one test program, and that change will apply to all of the part numbers that are based on that program. So going back to the choose a test screen, the final option is make a test. This allows you to put together a straightforward relay test program from a prompting wizard. So here we can select that we will start with some simple defaults instead of using values from maybe a previous test program that we've used. We can type in a new program name, and then we can select the relay type. It might be a latching relay or a non-latching relay. Here we get to edit the details about the coil, so we can select that it's a 12-volt coil, and we can choose 10% coil resistance limits. Here we get to specify the voltages at which the relay must operate and must release. These will turn into the individual values in the test program. Here we get to program the operate time and bounce time, release time and release bounce time for the main timing limits of the relay. And then we provide some details about the construction of the relay. It might be, for example, a two-pole changeover, and the maximum contact resistance, which might be 150 milliohms. These are the individual test types that will make up our test sequence, and I can individually remove those, so you can then decide exactly what level of testing builds up into the test sequence. And finally we get to review the major limits for this part here in this screen. When we're happy with those limits, we click on Finish, and we're told that the test program is ready to run and the job's done. We can now go ahead and test. If we want to, we can go and look at the test conditions, and this is a test program that's been automatically generated from that wizard. So this is a very quick way of just getting started with a simple relay device without getting bogged down in a lot of the advanced options that can be set in the test program.